Hello again, and welcome to some more exam question examples for permutations and combinations, number 5. So in the first question, we are creating a 4-digit password and we're allowed to use the numbers 1, 2, 3 and 4. How many passwords can we create if we're allowed to repeat as many times as we want? Well, this is relatively straightforward because we have 4 digits, so there are 4 choices of number for the first digit. There are 4 choices for the second digit, 4 for the third and 4 for the fourth. So it is 4 to the power 4 or 256. But if there are no repetitions allowed, we'll have 4 choices of number for the first digit, but we'll only have 3 left to choose from for the second digit, and 2 for the third and 1 for the last digit. So the answer here is 4 times 3 times 2 times 1, or 4 factorial, which is 24. Next, we're told that for security reasons, you can repeat a digit at most twice. And we have to work out the probability that a randomly generated code will comply with this security requirement. So first we have to work out how many codes there are that do comply with the security requirement. So first we're going to work out the number of passwords with 2 repeated digits. So if we write down this little table, we can see that if we just use 1 and 2, there are 6 different arrangements with those 2 numbers. However, we can also make this table with 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. So in total, we could make 6 different tables with these different number combinations. So if we have 6 different arrangements in the table and there are 6 different ways to organise the numbers, we'll have 36 different ways of having an allowable password with 2 repeated digits. Next, we have to work out how many passwords are possible if only 1 digit is repeated. So to start with, we'll write down a table where the numbers 1, 2 and 3 are used and the number 1 is repeated twice. And as you can see, there are 12 arrangements, but this is also possible with 1, 2 and 4 and 1, 3 and 4. Therefore, there are 12 times 3, which is 36 different arrangements. But you could also do the table where 2, 3 or 4 are repeated. Therefore, we have to times 36 by 4, which gives us 144 arrangements where only 1 digit is repeated. And remembering that there are 24 arrangements where each digit is used just once, the total number of arrangements that meet the security requirements is equal to 36 plus 144 plus 24, which is 204. So the probability that the code complies with security requirements is 204 divided by 256, which reduces down to 51 over 64. So next we have the letters of the word examination written on separate pieces of card. What's the number of arrangements you can make using the 11 letters? Now if we write down examination like this, we can see there are 2 A's, 2 I's and 2 N's. Now as we've spoken about in previous videos, the arrangements of 11 items should be 11 factorial. However, in this case, because there are 2 A's, 2 I's and 2 N's, we divide by 2 factorial, 2 factorial, 2 factorial. Alternatively, you could use the permutation formula to work out the answer, remembering that 0 factorial is equal to 1, but you still have to divide by 2 factorial, 2 factorial, 2 factorial. To work out the probability that exam appears in one of the arrangements, we treat exam as one unit, so we effectively have 8 items to rearrange. Therefore, the arrangements with examine is equal to 8 factorial, again divided by 3 times 2 factorial, which gives 5040. So the probability is the number of arrangements with examine divided by the total number of arrangements, which gives 0.001. Next, we have to work out how many possible committees you can pick of 3 people from 4 women and 5 men if the married man and woman are not allowed to serve together. So here's the combination formula, and we're going to write down the women and men, and we're indicating the married couple in green. So first we're going to write down the possible committee selections if the married woman is in the committee. You need a person from each gender, so you could have another woman and 1 man, or you could have no more women and 2 men. So if we choose the married woman, there is only 1, so there's only 1 way to choose her. But for the next woman, there are 3 choices, so it's 3 choose 1. And for the man, we cannot include the married man, so there's 4 to choose from, 4 choose 1. If you calculate this out using the equation, you'll end up with 12. And for the next row, we are not choosing any more women, so you have 3 choose 0, but 2 men, so you have 4 choose 2. And again, if you put those numbers into the equation, you'll end up with 6, which gives a total of 18, where there's the married woman in the committee. If the married man is in the committee, we could have 2 more women, or we could choose a woman and a man. So for the first scenario, there's only 1 married man, so there's just 1 choice. But for the 2 women, we have 3 to choose from, and we can choose 2 because we mustn't include the married woman. And for the men, there's 4 to choose from, and we don't choose any. And for the second row, we have 3 women and we're choosing 1, and 4 men and we're choosing 1. Calculating this out, we end up with 3 and 12 respectively, giving us 15 ways the committee can be organised if the married man is in it. And finally, if we choose a committee without the married man or woman, we could have 1 man and 2 women, or 2 men and 1 woman. This gives us 4 choose 1 times by 3 choose 2, which is equal to 12, and 4 choose 2 times by 3 choose 1, which is 18. So there are 30 different ways to organise the committee without the married man or woman. So the total number of committees possible is 18 plus 15 plus 30. So the answer is 63. So thanks again for watching. I hope you're finding it easier the more examples we've been through. And as always, if you could like and subscribe, I'd really appreciate it. Thank you, and see you on the next one.